Today we're going to do the most boring lab of the year. No, I'm not kidding. This is the most boring lab of the entire year. Alright, so today what we're going to do is the Conductivity Lab. For the Conductivity Lab, we are going to watch ice melt. I know, it's going to be fantastic. It's a good thing you're sitting down. Hopefully you're sitting down for this. So for the Conductivity Lab, we have conductivity boards here, and there are several different surfaces on the conductivity board. The first one right here is a piece of wood. There is a piece of glass. Be careful not to cut yourself. The edges can be sharp on some of these. There's a piece of metal on here, and there's a piece of styrofoam that are that's on the conductivity board. And what we want to do is we'll put an ice cube that's about the same size, as close as we can get, on each one of these conductivity boards. For each ice cube, we're going to first find the mass of it at the very beginning. We'll put it on the conductivity boards. Then the fun begins. Then we'll let it melt for about 15 minutes. It depends on how warm it is in the room to see for it and everything. Then towards the end of the lab, well, we'll go back in, and if there's any ice left that hasn't melted on the different surfaces, we'll again check, starting with whichever one we put down first will be the first one that we check, and we'll see, find the mass of, well, the ice bits that are remaining for it and everything. So the first step in the Conductivity Lab is to try to make your hypothesis. Which one of these do you think is going to melt the most? Which one of these do you think is going to melt the least? And, you know, kind of rank them 1 to 4 and everything like that. The element that conducts the best is going to be the element where the basically the ice cube melted first, or melted the most. So if you think, let's say, the piece of glass right here, the ice is going to melt most on the piece of glass, what's happening is it's being conducted. The heat is being conducted. So the energy, you know, that's inside of that ice cube, it's being transferred into, you know, the piece of glass or the piece of wood or metal or styrofoam for us. So the one that is the least conductive, right? So from these 4 materials that we have here, the one that's the least conductive, well, obviously that's going to be the one where the piece of ice is the most intact still at the end of the lab. So let's get started as soon as we can here. Before beginning the experiment, make sure you make a hypothesis. In our case today, do you think it's going to be the piece of wood, the piece of glass, the piece of metal, or the insulation that's going to have either be the most conductive or be the least conductive? So basically we're rating them from 1 to 4, right? 1 being the most conductive, meaning it's going to melt the most, and 4 being the least conductive, right? It's going to be intact the most. So what we'll do is we have a bunch of ice cubes here, and we're going to find the mass of each one of them. So ice cube number 1. Let's see what happens with ice cube number 1 with our triple beam balancing measuring skills here. It's going to be 10 at least grams. As we kind of test this out, I think it's going to be 12 grams. We're going to call that 12.56. Let's say 12.7 grams. All right, 12.7 for ice cube number 1. And we'll put it back here on the wood block. Ice cube number 2, right? Now the ice cubes are not going to be the same mass exactly, but what we're going to look for is the biggest difference. All right, so the biggest difference right here is going to be, it's going to be 16, say 16.5 maybe. Oh, just a little less, 16.3. There you go, close enough. 16.3. All right, so ice cube number 2, 16.3. Ice cube number 3. One here. They're slippery. They're slippery. All right, it's going to be a little bit less. It's going to be at least 10, 13. No, 12 point something. 12 point maybe 8, 12.9. There we go. We're going to call it 12.9. Ice cube number 3 is 12.9. Oh, it's trying to get away. It's trying to get away. There we go. Okay. And then, let's see here. Ice cube number 4. All right, ice cube number 4 is a little bit bigger again. So we're going to say it's 15, not 14. It's 14.5. We'll say 14.5 grams. Put it on there. 14.5 grams. So let's see what the results were for our mini experiment here. All right, if we start with the piece of wood, all right, ice cube number 1. All right, let's find out and see how much mass is left on that guy. So, at least 4. Okay, it's around 7. Let's say 6.5. Let's say 6.7. All right, 6.7 grams is what ice cube number 1 was. Ice cube number 2. Okay, ice cube number 2. A little bit heavier. Is it 10 grams? Oh, it's not quite 10 grams. It's going to be 9.6, I think is what we're going to call it. Yep, 9.6. All right, so ice cube number 2, 9.6. Ice cube number 3 is non-existent. All right, so ice cube number 3 is 0 grams. And then ice cube number 4. All right, let's try ice cube number 4 here. Ice cube number 4 is a biggie. All right, it's at least 10 grams. Let's see here. Let's say it's not quite 12. Let's say 11 grams. Okay, it's going to be 10 point something. 10.7, we'll say. 10.7. Now for the math. Results. What we want to do is get to the results of the most boring lab of the entire year. So, on ice cube number 1 was on the piece of wood. We started with 12.7 grams, ended up with 6.7 grams, so that gives us a nice even 6 grams. Ice cube number 2, right? So ice cube number 2 on the piece of glass. It started at 16.3 grams, it went down to 9.6 grams, so it was at 6.7 grams. Ice cube number 3, the one on the piece of metal, started out at a whopping 12.9 grams and was all the way down to 0. There was just a puddle left at the end of that. So that means all 12.9 grams were absorbed or conducted. Ice cube number 4, the one on the piece of foam, started out at 14.5 grams. It went down to 10.7 grams, so it was 3.8 grams. Right, so as far as conductivity goes, the one that had the highest conductivity or the one that changed the most was the most conductive. And that's definitely the piece of metal at 12.9 grams. Right, so metal was, as expected, the most conductive thing that was there. Number 2, though, was the piece of glass. At 6.7 grams, glass conducted, well, the second best out of the 4 materials, followed by the piece of wood with just a nice even 6 grams. And then, if you think about it, the piece of foam or insulation, it only changed by 3.8 grams. And that would be kind of expected because think about it, foam insulation is designed not to conduct heat very well, right? And that's what we were testing in this experiment. Hopefully your hypothesis was at least somewhat correct, or you got at least part of this lab right. Make sure to check out the quiz at the end so you get credit for doing the lab.